Now we'll follow an example of that's a little bit more familiar because when we typically push on crates in the real world, there's friction, and friction acts as a force that generally opposes the motion that we're applying, or the force that we're applying. And if we were to graph what happens here, we'll again look at the velocity as a function of time for a scenario where we're pushing on this crate. So if I were to push on this crate, I know that I have to push awfully hard because there's a friction force that's opposing me, but I'm applying a much bigger force to the right compared to the friction force to the left, and so it was accelerating. But then when I stop pushing, there's still friction opposing, and it's bringing the speed back down again. If I apply a force again, I can make the velocity increase because the net force is positive and therefore the acceleration is positive. But if I stop pushing, the net force is only the friction force, and therefore it's in the negative direction, and so the acceleration is negative and the velocity decreases. If I try pushing the other direction, my applied force is to the left, it's negative, but friction is always going to oppose me, so it's going to become positive. And when it's positive, it's trying to increase the velocity, which in this case was negative, so now it's going to try and become positive, more positive, which means it heads back towards zero. If I were, instead of graphing just the velocity but also the acceleration, it's worth seeing this again. When I'm applying applied force that's bigger than the friction force, the net force is to the right, and therefore the acceleration was positive. But then when friction is all by itself, the net acceleration is negative, and the velocity decreases. I can again apply a big force right here, in which case the acceleration is positive, and the change in speed has a positive slope. But once I stop, the only force left is friction, and the slope of this curve is now negative because the acceleration is negative. Now I want to go in the other direction. I'm applying an applied force to make a negative acceleration, or it's to the left. But when friction is always opposing the motion, it wants to make a positive slope to velocity, which means since velocity was negative, it's trying to bring it closer to zero.